Hello and welcome to TidyX episode 68. TidyX is a screencast where we go through and explain how our code works. My name is Ellis and you can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSP Patrick, and Tidy Explained is on Twitter at Tidy_explained, or on Gmail at tidy.explained@gmail.com. Or you can like and subscribe on the YouTube channel, leave us comments, questions, etc. We do get back to those, as well as you can go on the GitHub repo, open up an issue. Ellis opened one today. We've had people open some before. We've been cleaning messy data, courtesy of some viewers as well. So we do respond to those, and feel free to ping us.
Yeah, sweet. All right, so this week is episode 68, and we've already gone through the last several episodes: data ingestion, some data cleaning, data manipulation. But now you have all this clean data, but how do you actually share it out, right?
Yeah.
Like, because we've done all this work to clean it, but maybe we're not the person that does the final analysis. Maybe we just want to actually have a pipeline where we take in dirty data or ugly data that our users or that our fellow team members may create, not knowing that it's ugly to us. And we want to output it into a standardized, hey, like if you want to pull in clean data that's consistent, go here. And it's just like, that's a good thing to do.
Yep.
So we're going to go over some methods for, now that you've cleaned the data, how to output it in different ways. So let me share the screen so Patrick sees what we are seeing, and then we can get going here. All right, so as always, the first chunk of code is loading in our libraries. So we have tidyverse, readxl for reading the Excel file that we got sent, lubridate for handling those date objects, janitor for general cleaning practices, and then we have these two new libraries here: library writeXL and library Openxlsx. Patrick, what are those?
Those are going to be the packages that help us write our data out, primarily to Excel. We're going to write to CSV as well, but we're going to show some options for writing to Excel, since that seems to be, for most, kind of end users, the non-technical analysis people, that seems to be the preferred way of ingesting this kind of information. So writeXL is obviously the pair with readXL, so they kind of go together, and obviously one reads the data in and one writes it out. And then Openxlsx is a package that I hadn't used before. Ellis brought to my attention, but it can do some cool things because you can actually format from the Excel sheet into the way that you want to see it, and then spit it out to a folder, and it is now in a not only clean data form, but in a form that might be used for a report. So like traditionally where we do this is I'd actually write it out to Excel, and then I'd go in and I'd format the cells how I want. We could just do that straight from here, which is pretty cool.
Yeah. Openxlsx is an older package as far as I'm aware. But yeah, definitely gives you a lot more granular control over your output files. And the reason we need these packages too is Excel files are actually a very interesting binary. It's a zip file under the hood with a bunch of XML under it that I don't even claim to try to understand. I just know that that's what it's formatted as. So we've spent enough time talking about that. Let's get actually into what we said we were going to do. So I am going to get the directory to the to this folder here that I'm working in, just so that I can output stuff to the correct folder. So let's run that. And then everything here is episodes 64 through 66. So this is loading the data, this is cleaning the data, and we're not going to spend any time on this right now. We're just kind of run it because we know it all works. We went through it in depth. Those episodes, if you want to learn more about those are very quick episodes. They're roughly 20 minutes a piece, maybe 25 minutes. But you can learn all you want around cleaning and dealing with ugly Excel data in those episodes. But now we're going to get on to, all right, now we've got our clean data. How do we output it?
Yep.
Go for it.
Well, the first one we'll do is just write to CSV. Again, most of the time, the end user is probably going to want this in Excel. Writing to CSV is usually, probably for most data analysts, one of the easier ways, unless you're writing it out to like a specific R-type data file, an RDS or an RDA file. So write CSV, this is the base R function, and then in a second we'll use the tidyverse read R function. In this, all you have to do is literally pass the function the data set. So this is going to be our clean data that we created, and we're going to give it a name. And so within this name here, we're going to specify the file path. If we weren't using a specific file path, we would just have the name player_data.csv. But here we want it to output directly to the folder where our colleagues are going to be able to access it. So we specify our file path. And then I usually set row names to be false, mainly because if this has to go into like a SQL database or something like that, and there are row names, it's going to break the schema. So I always set row names to be false. There can be instances where the row names are meaningful and you want to keep them. For example, if the row name is like specifically an ID of each row event, that might be something that you want to keep. But more often than not, I'm setting my row names to be false.
Yeah.
And that's pretty much the base R version of write CSV. Ellis, you want to do the read R tidyverse version?
It's basically the same. I mean, the whole writing out to CSV files is really not that complicated, especially if you have. So these all have to be like a data frame or a matrix. They have to be a flat data structure. You can't write out like a complicated list or a very strange object. It's not going to work. Or you need to write your own method for how to output that. But here, same idea, you pass the data set that you're wanting to write to a CSV, and that is the argument X, and then the file name that you plan on writing to, and you may or may not include the full path to where your fellow teammates expect it to go to. The difference between these two is by default, I believe this doesn't save the row names. That's just kind of a change in the paradigm of the way that people think about the value of row names. Well, not value, the
utility.
Whether people think that you should use them.
Yeah.
Basically. So we'll not get into that. That's another story for another time. But they honestly will basically produce the same thing. It's just a comma delimited text file. So this is just writing into our folder here, and now we've got player data and player data CSV. And they are simply text files. They are nothing complicated. I mean, visually they're kind of hard to parse. But really what matters here is we have a header column here, and then it's separated by columns or commas, which is why it's a CSV. So comma separated values, CSV. And so yeah, it works out pretty nicely. But that's not usually how a lot of your teammates, if they're not data scientists or programmers, will be wanting to ingest their data. They want it visual. That's why they gave it to you in an Excel file to begin with.
Right.
So we're going to write out to an Excel file for them again, going, hey, we took the data in, we cleaned it up, and saved it in this location so you can start doing your stuff with. And from the write Excel package, there is a handy dandy write_Xlsx function, and it has very similar arguments to the other ones because conceptually it's kind of the same thing. I mean, it's just a different output file name. So we have the data that we want to write to. Once again, it's got to be flat. The file path that we want to write to, and note these have to end in Xlsx. So this had to end in, or it doesn't. I guess it didn't have to, but this should end in a CSV. This should end in an Xlsx. And then right here, we specify that we want to include the column names in the output. Because sometimes you may not want to. So we write that, and that will, here, let's kind of open that up there. But now we've got player data.xlsx in our folder. And this is now an Excel file containing all the data that we want.
All on one sheet. All in one sheet.
All in one sheet, all located there. Aaron
it basically
Peter Mills.
took our clean data as it sat in that flat table and plopped it out into this simple Excel file.
And one thing to note by default is NA values are blanks in Excel and in CSEs. Is that true? Yes.
Yeah. That's right.
And so if somebody's like, hey, you've got some blanks in this data set that you're giving me, it's like, well, it's because they're NA in the data that you
or it's because you didn't input any values there.
Yeah, this is a
you forgot to write.
You did that wrong.
Don't complain to me.
I just took what you gave me. Yeah, so we got that one. So that's a pretty simple one. It writes to a single sheet.
Yeah.
It's pretty easy, but that's not super helpful.
No.
Why?
well, it's not helpful because a lot of times if you think about the way that we got the data in, the data lived on separate tabs for each individual athlete. And oftentimes, that's how the consumer is going to want to see it, by broken down by some sort of level grouping. Maybe it's athlete. For example, like if you were in a sport, you might have a tab for defensive backs, defensive linemen, or forwards, point guards, centers, right? So you're going to want to write it out into those Excel sheets in the manner in which they're going to want to consume it. Otherwise, they're going to have to be, if it's a non-technical audience, they're going to have to try and figure out how to filter and do all that kind of stuff.
They don't want to
so I'll give you kind of two ways of writing this out to Excel in using the Write Excel package, and then Ellis will crank through the Openxlsx package. So writing to a separate sheet is pretty easy. You just need the data in a list format so that the Write Xlsx function knows that the data is supposed to go to separate sheets. So it's going to take each list and say, oh, list 1, sheet 1, list 2, sheet 2. So the first way that I do this is actually manually breaking each player down into their own data set and then wrapping them into a list. So that's what I do on line 180 there. So I'm just literally filtering out one athlete at a time, creating two separate data frames, wrapping them together in a list. So if we ran that athlete list, you'll see two elements within that list. So each element of the list has its own data frame specific to each individual athlete of the data that we cleaned. And then I literally just do the exact same thing as we did above, except I pass my list in, and that's going to drop the data out into two separate sheets. And there's only two problems with this. Problem one is that the sheets aren't named, so the end user doesn't necessarily know that Aaron Jacobs is going to be on sheet 2, and Peter Mills, I believe was his name, or Peter Mills is on sheet 2 and Aaron Jacobs is on sheet 1. And the other issue is this is 2 people. What if we had 100 people? So this doesn't really help us. So we're going to solve that next. And the way I'm going to do that is I'm actually going to use this split function. So the way this works is I take our clean data and I'm going to drop a pipe at the end of that. And I'm going to say, hey, I want you to go ahead and take this clean data and I want you to split it on the player number, which in this case is the player name, so since we're not using IDs. And so what it's going to automatically do is it's going to split those people, or split the data into a list, and it's going to identify each unique player's name and actually name the list for that player. And so as a consequence of that, we now have a named list where each element receives the name of the player. And because the element of each list is named, when we pass it to our Write Xlsx function, what we end up with is the function knowing, hey, go ahead and name the list, or name the tab by the name of the element within that list. And so now we have a pretty nice little Excel file that is user-friendly. And then if we want to kind of take it to the next level and do a bit of customizing so that they don't have to, essentially helping them create the report that they might want without them having to do the heavy lifting, we can go with the Openxlsx functions, and that's what Ellis will walk through now.
Sure thing. Yeah, excuse me. The way that Openxlsx works is it's kind of like a more old-fashioned, at least to me, it feels a little bit more old-fashioned way to approach creating that, where you initialize some sort of object and then you kind of add pieces to it, and then at the very end you're like, okay, now write to here. So we're going to step through that. So we have create workbook, which creates this object that I will then be assigning values into. Here we're going to create a header style. So like we said, this gives us a lot more ability to control formatting and details in the output Excel that we don't get with Write Excel. And normally I would say this really doesn't matter. This is really not helpful. It's kind of a waste of your time to do that. But you know, you might have an end consumer that expects like a really nice Excel file output from you, and this is the way you can go about doing that. So we're going to create a style. So this is going to add design elements into each cell that you specify. And so we're saying the foreground fill should be this, or FG fill, the H align. So this is the left, right, or center alignment. We're going to center it. We're going to text decoration, so italics, bolds, underscores, we're going to make it italic. And then we're going to have a border along the bottom. So that's border bottom. And this is a style that we're then going to be able to add to our Excel file. And now we're going to try to create, you know, a similar Excel file to what Patrick had before, where we had each player on its own worksheet. And so we're going to use a for list, or a for loop, to do that. So for each player inside of unique player data, or training data cleaned player number. So this is going to give us the two names of our players, Aaron Jacob and Peter Mills. So for each player, we're going to add a worksheet to WB, which is our workbook, and this is the name of that new worksheet, right? And so we're going to set that to be player. So that's going to be Aaron Jacob or Peter Mills. Then we're going to write in the data to that worksheet itself. So we once again have the WB that we're writing to, so the workbook. We're going to have the player, the worksheet that we're writing to. So in this case, it's just the player name, so Aaron Jacobs. The data that we're going to be writing to it, and here I'm taking that same list that Patrick generated earlier, which is the named list of the two players that we have, or n players that you have. And then here's where we're really going to be assigning all our styling and whatnot. So all our unique pieces that we couldn't do in the Write Excel framework here. So start call represents the upper left-hand corner that we're going to be starting at. And so this is saying we're going to start on column 2. So one row in, and we're going to start on row 3. So start row 3. So 3 rows down will be where we write to first. We're setting row names to be false. Excuse me. Row names to be false, which means we don't want to output row names to keep up with the same thought process that we were doing before. We're going to set borders to be surrounding. So this means it's going to have a border around our entire data set that we're adding to it. And the border color is going to be black so that it pops. And then we're going to have a header style. And this is where we're going to be assigning that the styling that we created here, the HS1. And really we kind of just took the examples out of this code here out of the examples and just assigned it to our specific data. So if you want to learn more about all the different styling options that exist inside of Openxlsx, look at their examples. They're very detailed and have a lot of information around that. So you should definitely check that out. And so we're going to loop over each player, add their workbook in and add their data in. And then in order to save that output, because right now we actually haven't output anything. It's just saved inside of this WB object. We're going to run save workbook. Same idea where we feed the file path to it. And then we're going to set this option here, override as true. And you may not see that very commonly. Actually, here, let me quickly run all this first so we have that all prepared. So if the this is kind of a thing that I don't see a ton of these days, but it's a nice protection mechanism to prevent you from accidentally overwriting a file that you've already output to, unless you intend to do so. So we'll run this once, and you can see here we've got player data 4.xlsx, which is our new file here. And let's take a quick peek at this just to see what it looks like. Give the computer a second to open things up. It's struggle busing at the moment. Don't save. Close U2. There we go. But as you can see here, we have a pretty nicely formatted Excel file. We've got our nice formatted headers here. We've got the data set in here. We've got it for Aaron Jacob and Peter Mills. They both start 3 rows down and 1 column over. So it's not like hugging this upper left here corner here, because visually people don't like that for whatever reason. So
that's pretty cool.
So yeah, we've got all this thing here.
I wonder if you could do within that like conditional format a column, or if you can do multiple, you probably can do multiple like bold and italicize the headers and things like that. I wonder if you could also remove grid lines. Like I wonder how much functionality they actually give you.
I think you've got a lot.
Really?
So
yeah.
You can do a lot of stuff and make a very like presentation ready Excel
yeah,
file.
Yeah. It's pretty cool. Yeah.
But so now we've got that file there. But say we didn't remember if we wrote it or not. We're like, oh shoot, I need to make sure to write that. I just removed that override as true, and as you can see here, it actually checks to see if I already have a file with that file name in there, and it protects me from accidentally overwriting it. But most times you're going to be saying, actually, no, I do want to overwrite because you're doing it on purpose. And so we could maybe like remove this header style. We decided we didn't want that anymore. Granted, we have to rerun this whole thing, but it will now be the more boring version.
Mm-hmm.
There you go. But that's how you can write a more complicated workbook and write that out.
Yeah.
And you can overwrite it or not. Protect you from doing that. So let me undo that because we do want to keep that all there. I'll put that just so it's available. And here we go. Now we've got our pretty one again.
Yeah.
And with that, I think we're going to call it, because that is how you can, multiple different ways you can write to CSV, you can write to Excel, you can write to fancy Excel, you can write to multiple sheets. You can do everything you want to and more, and make your end users very happy with you.
Yeah. Easy.
All right.
Cool.
Let's call it. So once again, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward, and you can find me on Twitter at OSPPatrick. We're both on Twitter at tidy_explained, and we're both at Gmail at tidy.explained@gmail.com. And you can hit us up on the GitHub repo by taking out an issue. You can hit us up on YouTube when you like and subscribe and drop some comments at the bottom. And with that, I guess, what is this? This is 5 straight data cleaning episodes. So happy data cleaning.
Yeah. All right. Keep on exploring your world, y'all.